the allure of knowledge and its promises. It has captivated humanity for as long as we could think, walk on two legs, and learn to control fire. From the earliest cave paintings to the songs our species has ever shared, we have always been motivated to investigate, create, and develop. As centuries and millennia passed, we evolved not only physically, but spiritually and mentally. Humanity has evolved over millions of years and has reached its present stage of growth and understanding. Over time, we found answers to numerous questions that once eluded the greatest minds of history. Ancient scientists and philosophers pondered many of these mysteries. Gradually, they were solved by the scientific community, one after another. With each discovery, fewer and fewer things seemed impossible. Communication has become instantaneous. Diseases are being cured. Transportation, once slow and time-consuming, has become more rapid and effective. Yet despite these advancements, there's always a lingering question: when did it all begin? If you're curious about the beginning of time itself, the latest discoveries, and news regarding our universe, remember to like this video, subscribe to our channel, and press the bell notification button to stay updated. Throughout history, various theories about the universe's origin have emerged. One of the most accepted is the Big Bang theory. According to this theory, the universe was once compressed into a single, infinitely small point. Over time, this point began to expand, eventually becoming the vast universe we now observe. It wasn't until later that astronomer Edwin Hubble made a significant contribution through the study of galaxies moving away from us. The farther a galaxy is, the faster it appears to be moving. This observation supported Hubble's theory that the universe continues to grow. According to the findings, before the Big Bang, the universe consisted only of tiny, hot energy and light, mixed with particles. After the expansion, everything began to cool, allowing atoms to form. Over billions of years, galaxies formed and evolved into the universe we now inhabit. In 2021, the James Webb Space Telescope, JWST, the most advanced and costly telescope ever built, was launched into space. It functions by collecting infrared light, enabling it to look farther into space than any previous telescope. More than 1 million kilometers away from Earth, the JWST has an unmatched ability to capture images and process data. As astronomer Neil deGrasse Tyson pointed out, the farther the JWST looks, the further back in time it can see. At first, the telescope was anticipated to confirm the Big Bang theory. But the initial images it captured raised some intriguing questions. The first public images from JWST showed galaxies that were small, smooth, and remarkably old, contrary to what many scientists expected. You might wonder how this challenges the Big Bang theory. These observations have raised significant reservations regarding the model. For instance, in the JWST images, galaxies that should be farther away appear smaller in size, which contradicts the expectation that the farther a galaxy is, the larger it should appear due to the time it takes for light to reach us. In examining the differences between galaxy sizes in new JWST images compared to earlier data, scientists observed galaxies that seem smaller and some with redshifts 2 to 3 times larger than predicted. One of the most perplexing images shows a large group of galaxies all appearing the same size, raising questions about whether the universe is actually expanding at all. If the Big Bang theory is correct, galaxies should appear smaller due to the optical illusion of their distance. Additionally, some of the JWST images show galaxies that are surprisingly smooth. According to current theories, galaxies should collide and merge, producing irregular or distorted shapes, a phenomenon known as Mighty Mouse galaxies. However, the JWST shows galaxies that are unusually smooth, suggesting that galaxy mergers may be much rarer than expected. These observations cast doubt on the concept that galaxies grew large through frequent mergers. Moreover, the discovery of what appear to be billions of ancient galaxies raises further questions. If these galaxies have existed for so long, they should have already been consumed by cosmic processes. According to the Big Bang model, the farther we look, the fewer galaxies we should see, as older galaxies would have disappeared. Yet JWST has captured images that seem to contradict this prediction. The galaxies appear more abundant and larger than expected, leading to an important question. Could so many galaxies have formed in such a short period of time? Many scientists find this highly improbable. However, there is an alternative model, plasma filamentation theory, which provides a potential explanation for these inconsistencies. This theory, around for over 5 decades, suggests that electric currents and the magnetic fields they stimulate pull plasma into filaments, which are found throughout the universe. Plasma filamentation is known to play a key role in the formation of planets, stars, galaxies, and other cosmic structures. When large clouds of gas and dust are pulled together by gravity, they can collapse into a protostar. This collapse is sometimes aided by plasma filaments that support energy transfer and momentum. Once a star forms, it may be surrounded by gas and dust, protoplanetary material, from which planets can eventually form. Plasma filamentation can influence the dynamics of this disk, although it is not directly involved in planet formation. This theory also plays a role in efforts to create fusion energy artificially, a process still in early stages but one that may one day provide a significant energy source. Whether through plasma filamentation or other emerging theories, unlocking the secrets of the universe's creation is still ongoing. As research continues, it's possible that new theories about the universe's origins will emerge. But for now, much remains speculative. As we proceed to explore the mysteries of the universe and question where everything came from, one thing is clear: the pursuit of knowledge is an endless journey. Our understanding of the cosmos has evolved drastically over centuries, and each new piece of information raises more questions. While the Big Bang Theory has long provided answers about the universe's inception, the most recent data from the James Webb Space Telescope has cast doubt on some of its foundational assumptions. These revelations remind us that science is not static, but a dynamic field that continually adapts to new evidence. The JWST, with its unprecedented capabilities, has given us images that challenge numerous assumptions about the early universe. These images depict galaxies that are older, smaller, and smoother than expected, an observation that defies the conventional understanding of galaxy formation. If the universe is indeed expanding as the Big Bang Theory suggests, galaxies should appear larger the farther away they are, not smaller. This inconsistency has led some researchers to reconsider whether the universe's expansion is happening the way we've always believed. Simultaneously, the lack of observed galaxy mergers poses another challenge to the theory. According to the Big Bang Theory, galaxies should collide and merge, leaving behind scars of their violent histories. Yet, the smooth, undisturbed nature of several galaxies observed by JWST suggests that mergers may be far. However, the galaxies observed by the JWST seem to defy this gradual formation narrative. Some appear to have complex structures, spiral arms, dense cores, and well-defined shapes, that indicate a level of maturity not expected so early in the universe's timeline. This suggests that either galaxies formed much faster than the Big Bang model allows, or that our understanding of early cosmic evolution is incomplete. The implications of these findings are profound. If galaxies can exist in mature forms just a few 100 million years after the Big Bang, then either the expansion rate of the universe is different than we thought, or the mechanisms driving galaxy formation are far more efficient and rapid than current models suggest. Furthermore, these observations invite us to revisit alternative cosmological models. Aside from plasma filamentation theory, other frameworks, like steady-state theory, modified Newtonian dynamics, MOND, or conformal cyclic cosmology, CCC, have gained renewed attention. Though each of these theories has its limitations, the recent anomalies have reopened scientific interest in exploring possibilities beyond the standard model. The scientific community now faces a choice: double down on refining the Big Bang Theory to account for new data, or begin seriously considering that the universe may be governed by different principles than previously assumed. In either case, this is a critical moment in our understanding of cosmology. But perhaps that is the nature of science itself, never truly settled, always evolving. What we once regarded as universal truths are often stepping stones to deeper, more accurate understanding. And as our tools improve, so too must our theories. The James Webb Space Telescope is not just a marvel of engineering, it is a reminder of our endless curiosity. It shows us that the universe is not a finished story to be read, but an unfolding mystery to be explored. Every image it returns is a puzzle piece, one that may fit, or may force us to redraw the entire puzzle. What lies ahead may not only reshape our view of the cosmos but redefine humanity's place within it. As we peer deeper into the void, one truth becomes increasingly clear: the more we discover, the more there is to question. So we continue, not just with data, but with wonder. Because in the end, it's not just about galaxies and theories. It's about us, our need to understand, to ask why, and to never stop looking up. With older galaxies being harder to detect, the JWST has captured galaxies that appear to be billions of years old, raising doubts about how quickly these galaxies could have formed. Were they really the product of an ancient cosmic event, or is there something else at play? These findings have compelled a number of scientists to think about different versions of the universe's creation, such as the plasma filamentation theory. Unlike the Big Bang Theory, which posits that the universe began in a single explosive event, the plasma filamentation theory suggests that the universe was created through the interplay of electric currents and magnetic fields, which directed the formation of galaxies, stars, and other cosmic structures. This theory proposes that the visible plasma filaments at all scales of the universe could have contributed significantly to the creation of the universe as we know it. One of the most intriguing aspects of the plasma filamentation theory is its potential to explain the observed discrepancies in the formation and size of galaxies. This theory holds that the process of star and galaxy formation could have occurred in a more gradual and organized manner, different from what the Big Bang theory suggests. Rather than a sudden, violent expansion, the universe may have evolved through a series of processes guided by the forces of electricity and magnetism. This could account for the smoothness observed in the JWST's images of galaxies, in addition to their surprising ages. While the theory of plasma filamentation is still a relatively young idea, it offers a compelling alternative to the Big Bang. The theory depicts a universe that is shaped by forces more subtle than previously thought, and it could provide the key to understanding the true nature of our cosmic ancestors. But like any other scientific theory, it must be tested and refined as new data becomes available. As our ability to observe the universe keeps improving, we might find that the answers to these profound questions are more complex than we could have ever imagined. On the brink of these new discoveries, it is important to remember that our understanding of the universe is still in its infancy. We have come a long way from the early days of astronomy, when the stars were mere points of light in the night sky. Today, with the help of advanced telescopes like the JWST, we are able to look further into time and space than ever before. But there is still so much we do not know. In the coming years, as we continue to refine and collect data to improve our models of the universe, we may uncover additional surprises. Maybe we will discover that the universe is even more mysterious and complex than we can currently comprehend. The possible responses to some of our most fundamental questions may lead us to rethink everything we thought we knew about the universe. As humanity continues its investigation, one thing is certain: the pursuit of knowledge will never end. We will continue to ask questions, seek answers, and challenge our understanding of the world around us. The science of the future is bright, and we are just scratching the surface of what is possible. So as we await the next wave of discoveries, we recommend that you remain engaged and curious. The more we learn, the more we realize how much there is still to uncover. And who knows, perhaps the next great breakthrough will come from an unexpected direction, challenging everything we believe to be true about the universe and our place in it. As we conclude this discussion, we invite you to share your thoughts and theories. What do you think about the Big Bang theory and the theory of plasma filamentation? Do you believe the universe is still expanding, or is there another explanation for the phenomena we observe? Join the conversation in the comments below, and don't forget to subscribe to the channel and activate the bell notification to keep up with future content as we venture deeper into the complexities of the cosmos. Keep in mind that the questions we are grappling with are not only scientific, but profoundly philosophical. Our attempts to understand the origins of the universe, the nature of time, and the possibility of other forms of existence push both our intellect and our creative faculties to the limit. Every groundbreaking discovery challenges the very foundations of what we once thought to be true. This journey into the unknown not only reveals the secrets of the universe, but also emphasizes the essence of our human condition, our relentless curiosity and our drive to understand the world beyond our immediate surroundings. When we speak of the universe's beginnings, we are talking about a moment far beyond our comprehension. The Big Bang theory posits that the universe began from an infinitely dense point, expanding outward and resulting in everything we know today. This concept has shaped our perception of cosmic history for nearly a century. Yet, as we have seen with the latest data from the James Webb Space Telescope, the picture may be more complicated than we thought. The images and data shared with the public challenge our understanding of galaxy formation, the expansion of the universe, and even the age of the galaxies themselves. While the Big Bang theory remains the leading explanation for the universe's origins, it is far from a perfect model. The discovery of galaxies that appear older and more fully formed than expected suggests that the processes of galaxy formation might have been much more rapid than previously imagined. Could it be that the universe did not expand as slowly as we once thought? The data from the JWST suggests that we might have to reconsider our current models and theories about how the universe evolved over time. These findings point to the likelihood that our understanding of the cosmos is far from complete. If the universe did not expand in the way we thought, what other explanations might there be? One such alternative is the plasma filamentation theory, which suggests that the formation of galaxies and other structures of the universe was driven not by a singular explosive event, but by the interactions of electric currents and magnetic fields. This theory provides an entirely different framework for understanding the formation of planets, stars, and galaxies, and it could potentially explain some of the anomalies observed in the first pictures. If these plasma structures are indeed responsible for shaping the universe, it opens up a completely new field of investigation, one that blends astrophysics with plasma physics and electromagnetism on a cosmic scale. Such an approach not only challenges the traditional models but also encourages a multidisciplinary perspective, where the universe is no longer viewed solely through the lens of gravitational dynamics and expansion, but also through the powerful, guiding forces of electromagnetism. The implications are vast. If galaxies, stars, and planetary systems were born out of these vast, cosmic-scale electrical interactions, then the universe might be far more interconnected and patterned than previously assumed. Patterns in cosmic structures, filaments, voids, and clusters, might not be random at all, but the visible footprints of electrical processes weaving the fabric of the cosmos. This challenges one of the core assumptions of modern cosmology, that gravity is the primary architect of large-scale structure. Plasma cosmology, while still controversial and not widely accepted by the mainstream scientific community, dares to ask whether electricity, not just gravity, played a crucial role in sculpting the heavens. As with any paradigm-shifting idea, the theory of plasma filamentation must undergo rigorous scrutiny. Data must be collected, predictions must be tested, and models must align with observable reality. It is not enough to propose an alternative theory, it must explain more than what came before, and with greater precision. Still, the fact that such ideas are gaining attention reflects the scientific community's willingness to entertain new possibilities. The beauty of science lies in its adaptability, its ability to evolve as new evidence emerges. It is this very spirit of inquiry that drives us to build better telescopes, to send missions deeper into space, and to question even the most established truths. As we continue to observe the early universe with tools like the JWST, we may begin to see clearer signs pointing one way or another. Whether we uncover evidence that supports the traditional Big Bang narrative or discover entirely new mechanisms of cosmic evolution, one thing remains constant: our drive to understand. In the end, the journey to discover how the universe came to be is as much about exploring the cosmos as it is about exploring ourselves. Our questions reflect our innate curiosity, our desire to find meaning, and our search for our place in the grand tapestry of existence. So, as you reflect on these possibilities, on plasma filaments, ancient galaxies, and the birth of everything we know, remember that every theory, every model, and every telescope image is a step toward something greater. And perhaps, someday, we will look back at this moment as the beginning of a new chapter in our understanding of the universe.